All right. Well, I want to welcome everybody here tonight. My name is Joel Kirschen. I'm the president of the CSI St. Louis chapter this year. I'd like to welcome everybody into the session tonight. This is one that we're starting up our live sessions again. A little bit of a hybrid here. We have some online and some live here. We do have a nice group here, and I think we have a nice presentation tonight. I did want to recognize one of our, actually is one of our speakers tonight, Mr. Steve Gantner. Mr. Steve Gantner was awarded the SCIP 2021 Education Award this year. So that's, spec writers. And so this is an award that's not even given every year. So congratulations, Steve. Good job. I wanted to promote one of the upcoming events on December 9th. We're having our holiday dinner. We'll be in St. Charles at Lewis and Clark Restaurant in St. Charles. The registration will go live here in the next day or two. And I'd like to invite everybody to sign up and join us for a nice evening out in historic downtown St. Charles. At this time, I think I'm ready to introduce George Everding. George, in addition to having his name on the board as a presenter tonight, is also on our program committee and is going to fill us in a little bit on some of the upcoming programs for the rest of this programming.
Welcome, everyone. It's great to be live and in person again, isn't it? Last year was a tough year for everyone. And we were able to, during that year, look at a lot of the ways the architecture and construction industry responded to COVID. We had to look at what the HVAC folks were doing with air quality. We had to look at how elevator controls were going touchless. The first program we did this year was a carryover from last year. It looked at door hardware and how that was responding to it. Tonight's program on construction failure, just to give you a little background, is something that I've been kicking around in my head for quite a few years now. And I submitted it for Construct, the CSI National Convention for 2020. Obviously, that convention didn't happen. And in the program committee, we were talking about would this be a good topic after COVID? Are people tired of looking at problems and failures and sort of bad things? The more we talked about it, the more we felt that because of what we saw in our response to COVID, it might be worthwhile to look at construction failure. So this is the opening of a series of 4 or 5 that we're going to be doing. 4 that we're going to be doing. Thank you, Steve. And we'll talk a bit about them as we get into the program. Our next program in January will be Len Tangus. Len even took part in our COVID, what do we do now thing. His economic construction forecast really addressed how COVID was impacting things. And I think it was pretty well right on in terms of what he said. So we'll be hearing from him in January. February, March, and April will be 3 panel topics. And they will all be dealing with an aspect of construction failure. And more importantly, how failure leads to improvement. And in May, we're looking at a panel tentatively titled "What to Do When Loss." So it's after we heard about the legal and insurance response to it. So that's kind of the year coming up. I want to see if I can do this here. It worked. those of you who chose not to come, and we certainly understand why you might not want to be here, but I gotta tell you, you're missing some great food. Today's sponsor, Paula, really did a great job for us, and we're well fed before we start. Stephen Bowles is our local rep, and George Ramsey, who is out of Minneapolis, came down to join us. And George, we're going to make you say a few words, or ask you to say a few words on behalf of Paula.
Well, thanks for having us. It's a pleasure to support you.
Now come up and do your job here.
Thanks, George. It's always a pleasure to join the St. Louis group. I'm based out of Minneapolis. I'm serving on the Northern chapter for the Treasury Committee for Region. And, I'm a big supporter of CSI, and it's great to see everybody and always willing to help and participate. So thank you. And thanks to Steve Bowles, the St. Louis chapter, put everything together. So thanks, Steve.
Thank you, Steve and George. I need to get my cheat sheet so we can tell what's going on here. Today I'll be talking a bit in introduction not only to what's happening today, but also what we're going to be doing for the rest of the year. Michael Berg will discuss a very interesting project that was a failure and actually injured and killed no one. And then Steve Gantner will be talking about his experiences with the 2011 Joplin tornado. Unfortunately, that was much more fatal. Yeah, much more deadly. So that's the outline of what we're going to be doing. Trial and error, as Calvin and his dad are discussing here, has been a means of problem solving for a long time. And I don't know if you guys at home can see this. Calvin and mom and dad are riding across a bridge with a sign that says load limit 10 tons. Calvin asks, how do they know the load limit on bridges, Dad? And Dad, of course, being a dad, has the right answer. They drive bigger and bigger trucks over the bridge until it breaks. Then they weigh the last truck and they rebuild the bridge. And Calvin says, oh, I should have says, dear, if you don't know the answer, just tell him. I thought this was appropriate for what we're talking about here because a lot of what we do in this business historically has been trial and error, and I think it still is very much part of what we do. The focus is not so much on the failure. We're going to need to talk about some tough stuff. And I have to tell you that in doing the research for the program that I was going to put together for this program, it was really difficult. There are a lot of things that could have been talked about tonight. Neil deGrasse Tyson has a wonderful little, very short 15-second YouTube where he's getting ready to speak and they're doing like, the sound check. And they asked him to say anything. And what he said was, the universe is a deadly place. At every opportunity, it is trying to kill us. And he's absolutely right. I mean, our little Earth in the scale of the universe is the only place that we can survive. And for people in construction, Earth is not exactly friendly. Gravity is not our friend. Particularly as we get older, gravity is not our friend. Hurricanes, tornadoes, earthquakes, wildfires. We have to deal with that in everything that we build. And what about human stupidity? Or human hubris? Or human just lack of basic knowledge? Not necessarily making mistakes, but just not understanding the right questions. Given all of this, the question really is not why so many failures occur, It's why so few do. And that's the focus for this year. We're gonna look at those things that we've done right in response to what we learned when things go horribly wrong. And because we're all together, we're gonna do quiz the audience. And actually, if you have questions at home, please put them in the chat. We'll ask Hank to ask them. But my question to you all is, like a lot of response, one at a time. When you think about failure, what leaps into your mind? It can be a personal project that you worked on. It could be something in the news. When we talk about failure, George, the recent collapse of the condo. Anyone else? Why you guys are shy? What? I Regis in Kansas City, right? All of us who were licensed at that time had to pay twice our fees in order to defend that. The Missouri board was involved in that. Anyone else? 35W. I-35W in Minneapolis. George is probably painfully familiar with that. Yeah. So someone else, what about like a product rep, something that happened in their experience in dealing with product? It doesn't need to be notable. The what?
Windows, design pressures.
Yeah. George is talking about how Windows on Windows was not very well. Yeah, not very well known, and that windstorms and that sort of thing. Anyone else want to throw something out?
Too much moisture in the concrete slab.
Too much moisture in the concrete slab. That's something we've been dealing with for the last 20 years or so, and I don't know that it's still solved. Kevin?
I would say roofing early years of thermoplastic.
Early years of thermoplastic with roofing. So yeah, and that's something that, gosh, when I started as an architect, there probably were 20 different membranes, right? I mean, it just was all over the place, and many of them weren't as successful as they should have been. So what I hope to bring out in this kind of quiz was that failures can be large scale, right? I mean, we all think of the World Trade Center. I'm surprised that wasn't mentioned. The biggest building failure in this country. And it can be as small as, I see Drew in the back. I told him I was going to pick on him. Our local paint rep and president-elect. To Drew, a paint failure can be a client who's expecting a 20-year no color fade on their logo. And it turns from target red to target pink. That's a major failure to you. Or not to you, but the other guy, the other paint company, right? So this idea of failure as being large and small, I think is an important concept. Failure can involve death, lots of injury. As architects, we're certainly concerned about that. That's part of the reason we have a license, is to protect health and life safety. But a failure can also be an economic loss with no loss of life. So there's a big spectrum. Not advancing here. Oh, here we go. One definition of failure, and see if you all like this. The building or component loses its ability to perform its intended design function. Now, the failures that we mentioned, is this pretty comprehensive that it would cover the failures that we've all talked about, right? Obviously, the bridge failure is pretty straightforward. Drew's paint failure, Kevin's roofing failure, same thing, right? The product or the component doesn't work. a catastrophe. And this is actually from the U.S. Code. A catastrophe is defined as a natural or man-made disaster with extraordinary level of casualties or damage. I think we can all agree with that. There's probably a number of other ways we can define that, but a catastrophe is big scale. Now, NASA defines a catastrophic failure as sudden and total failure from which recovery is impossible. Think the space shuttles, right? The interesting thing is that these last two are in a little bit of a conflict. You can have a catastrophic failure without a loss of life. If the entire system is damaged to such a point that it cannot be used, that's a catastrophic failure, right? And I'll go into this a little bit more as we go through it. So here are some 4 different areas of failure. Structural failure, many of the ones we talked about were structural. A performance failure, our product reps, that's kind of what you deal with. Aesthetic failure is the paint fading, right? And a financial failure. And the financial failure is sometimes as a result of the other types of failure. Sometimes it's separate from it. You can have a structural success, a performance success, and aesthetic success, and still have the failure. And the other thing is you don't have to be in one of these areas. You can be in many of them as we go through, right? The cause of the failure. Proximate cause. Think of proximity. It's the direct cause. It's what happens immediately before the failure that results in the failure. And if the proximate cause isn't there, you don't have a failure. I'll explain this a little bit before we get off the slide. Root causes are underlying causes. There are generally multiple root causes in a failure. They contribute to the proximate cause. So to give an example of this, I think you mentioned Hyatt, right? The Hyatt Regency. The proximate cause is a weld failed, allowing the supporting rod to pull through a box beam, causing the walkways to fall. If that hadn't happened, if it had survived that T-dance with people jumping up and down, there wouldn't have been a failure. Now, it may have happened the next week, right? But that's why it's a proximate failure. That's what actually caused the problem. But the root causes are that the design was structurally incorrect. And the design was structurally incorrect for a couple of reasons. One, the dance party was a much higher load than anyone anticipated. And two, the design of the connection was changed. And it was changed because the design of the support was difficult or impossible to build. Steve and I were talking before when we were putting this together, and he mentioned that in Joplin, the proximate cause as well, the tornado, right? The root causes of the damage, but the fact maybe that the sill plate wasn't anchored to the foundation, or the roof structure wasn't anchored to the wall. So the important thing to keep in mind is that the reason you want to go to the root causes is you can identify the underlying problems. And all of us, whether we're an architect or a product rep or a contractor, in our organization and in our process of doing things, we want that to be correct, and we want that to be such that we can avoid the problems that cause failure. So root causes, sort of analyzing them, understanding identifying where the problems are and ultimately correcting those problems is key to what we're going to be talking about here. And then final slide here, to classify failure, human error, natural causes, or both. Right? Those are basically the choices here. Fire, explosion, weather, you can read the list. And I don't know, I'm not claiming this is a comprehensive list, but I think it's probably pretty good. I'm going to use these as we go through with each of the examples that they talk about and try to identify where these failures occur. The interesting thing is that, again, you can have a crossover here. The San Francisco earthquake in, I didn't put the year, it was 1903 or something like that. The San Francisco earthquake devastated San Francisco. But the devastation, 90% of it, was not the earthquake. It was the fires that came along afterwards. Failures, and I think the Steve Bowles and may have been Drew at one of the meetings that we had. And I said that my impression was that material failures, material itself, the product, very seldom fails. We've got a really good manufacturing, industry. And I asked Drew, well, in the paint industry, what's the percentage of failures that are not material? They are either installation or surface prep. Installation or surface prep, in my experience, it's been a big thing. And you said maybe 90% is installation or surface prep. And Steve said, well, it's higher, for us. And I never really thought of it because manufacturing is complicated. What you guys do at Pella is complicated. It may not be the most complicated thing in the construction industry, but you've got to have light transmission, you've got to have wind load, you've got to keep the water out, it needs to open and close. A lot of things going on. Drew, God bless you, paint is a dumb material, right? Not to say that paint is not important. You're protecting steel and whatever, but the paint manufacturing process, after however many hundreds of years we've been doing it, is pretty good. And then, as far as economic failure goes, economic failure is sometimes totally apart from what we as architects and contractors and even building owners do. Sometimes the economic failure is just the economy goes bad. And the building that we're building doesn't work. Those of you that were at my talk about the East Bridge. We love the East Bridge. Wonderful thing for St. Louis. The East Bridge was built, and within 5 years, it was an economic failure. So, who's to blame? Point some fingers. Me. Yeah, that often happens, right? Is that we get to dealing with the failure, and we start pointing fingers, and the blame can be just because we like grouping it this way in any of the three major parties: design, construction, or owner development, right? But sometimes we get to the point we say it's nobody's fault. It just happened. We're going to look at the hard things, and I'm going to need to go through.
George, one point that possibly in today's environment we're under supply chain disruption. I'm going to think about the wage side because it's kind of under economic development.
Right.
Horrendous issues that we're facing.
That's great, Tom Gant. Do I need to repeat the question for the
Yeah,
audience?
yeah, that's a good idea. We'll take it back to the.
Oh, okay, yeah.
You don't mind.
Under the environment we're all dealing with today, supply chain disruptions, kind of look into that category of economic failure, under the wage category, but definitely something we're all dealing with almost every building material that we're putting up building.
Yeah, I think that's really true, and it probably is as much an economic failure. And obviously, COVID was a big driving force for that. I think Len Tengus last year mentioned that as a factor that supply chain was tough. And he's probably going to talk about it in January as well. Okay, let's. Let's get into this. You're fine. Half the room, maybe a little more than half the room. This is something that actually I didn't learn about in any depth until I got involved with the door hardware industry. The Iroquois Theater had a horrible fire on December 30th in 1903, and it had been open for 6 weeks. It was a theater in Chicago. Obviously, they were taking advantage of the Christmas season. And they had just opened this Mr. Bluebeard play. Here's a copy of the playbill, and you probably can't see on the screen, but in the upper left-hand corner, absolutely fireproof. The theater was advertised as the biggest innovation in theaters in Chicago. It was the Showplace and the Palace. The proximate cause, sparks from a stage light ignited the stage curtain. And the building burned. You can see the results of it. One of the reasons that the first couple of tragedies I'm talking about so resonated with people was that newspapers were a big thing. And they were competing, and there were a lot of published photographs of the results of bodies, burned bodies, so forth. I'm not going to show them. If you have an interest in that sort of thing, you can find them online. But it was just horrible, just horrible. 250 people were injured, 602 killed. The root causes. The theater opened with no operating sprinklers. There were not enough exits. It was over capacity. People were sitting in the aisles, capacity 1,600, and there were possibly as many as 2,200 people in the house. Stairways were blocked with iron gates. You can see that in the upper left-hand corner. There was one interior stairway to get to the balcony, and there was a price difference from the main floor to the balcony, so they had that gate up, people going back and forth. Exit doors open inward, which is not against code at that time. Many exits were concealed by drapes. The exterior doors were locked from the inside. The fire curtain material, which should have been asbestos, wasn't asbestos mixed with wood pulp. So it wasn't a fire-resistant material at all. And there are indications of questionable code activity of the owner making deals with the code people to get it open in time. And sadly, I'm only listing maybe 2/3 of the root causes. This is a horrible event. But exit devices were invented as a result of this fire. How many lives have been saved by panic buttons, by exit devices, since this happened? And these came into effect almost immediately afterwards. Codes were changed so that exterior doors had to open out. To those of us in the industry, that's a no-brainer, right? We all understand that. Back then, it wasn't. New standards for fireproof stage curtains. And in terms of operation, in terms of management, cities prohibited standing in environments like this. So you can see that our world today is vastly different and vastly safer as a result of what happened as a result of the theater fire, the Iroquois theater fire. And we'll go to another one. This is maybe more famous. Who's never heard of the Triangle Shirtwaist? Yeah, Don't be ashamed. I'm not gonna point you out. One, maybe two. The triangles, well, let's define what a shirtwaist is. In the early 1900s, women would wear an overgarment when they worked that would keep their dresses clean, right? So it was sort of like a vest. And this was a real popular thing in the 1900s, 19-teens. This is a sweatshop. In the classic case, we've all learned about sweatshops, and this certainly was one. 146 people died in this fire. And they were mostly immigrant women. And there were a lot of girls, some as young as 14. You can see a kind of a nice picture of the work environment here. Picture that with the conditions when the fire broke out. These women are working on a piecework basis. They're working as fast as they can. That aisle that you see that's all nicely wooden there, that would be covered maybe a foot deep with scraps from people making shirtwaists. There was bins full of scraps. Approximate cause, an unextinguished match or cigarette butt was thrown into a scrap. And you can picture what happened as a result of that. The root causes inadequate maintenance of the working place. Exit doors were chained to keep the women from walking out with the product. There was only one key to the exit. The manager had it. The manager got the hell out of it. There were no audible fire alarms. The exterior fire escape, which they were able to get into, had been damaged prior to the fire and not fixed, and it collapsed. Elevators remained in use in during the fire. A lot of deaths is related to that. An interesting fact about this, we talked about the Iroquois fire, some questionable code practices. Cornell University is the sort of owner of documentation on the Triangle Shirtwaist fire. And they did a study 10 or 15 years ago and made the case that the Ash building, where this factory was, completely complied with code as it was written, right? This is an issue not so much of building code as ownership and management. The big deal about the Triangle Shirtwaist factory is it led to labor. It led to better working conditions. It led to training with fire drills and procedures. It led to a prohibition of locked exit doors. You can believe that, right? And a re-examination of elevator use during the fire, and then obviously management and maintenance practices. This fire directly led 20 years later or 30 years later to the institution of the U.S. Department of Labor. The first Secretary of Labor, Frances Perkins, who also was the first woman in a cabinet, was on the street when this happened. She was a labor reformer. She saw this happen. So her work towards that led to changes in labor laws and changes in things getting better. So these were the tough ones. I'm going to get a little bit better. Two more difficult ones, and then we'll get some where people don't die. MGM Grand Hotel fire in Las Vegas, 1980. First time you heard about it? Oh, okay, that's good. Deaths and injuries in fire don't always come from flame and heat. The first two we talked about, obviously, that was the cause of death. 85 people died in this fire. 650 were injured in it. Of 85 that died, only 4 died from flame and heat. You can see on the photograph of the building and fire there, the smoke on the outside of the building is coming from 1-story wing on the building that was restaurants and delis and that sort of thing. The owner of the casino negotiated with the building department to not put sprinklers in that thing. And the justification was this: this is a casino. It's open 24 hours a day, 365 days out of the year. There's always going to be somebody there. A couple of years after the thing is built, the deli doesn't need to be open. A compressor in the deli caught fire when it was closed, and that started the fire. We had 24 deaths on the first floor. No deaths on floors 2 through 18. And 61 deaths on the 19th to the 25th floor. What happened is that gases and smoke went up through HVAC shafts and the elevators, but more importantly, went through every crack and crevice that wasn't filled. Back in this era, there was little understanding of penetration fire stop. And that really was the worst part of this fire. I mentioned the approximate cause, the compressor fault. The root cause is lack of sprinklers. The elevators did not return automatically to the first floor. That's something that's since changed, and we do that now. No smoke evacuation in the stairwells, and flammable finishes were allowed on that first floor portion. It was estimated when they looked into it that flame spread 15 to 20 feet per second in that first floor. So, code, fire sprinklers are required now. Have you been in a hotel or a motel recently that did not have fire sprinklers? Probably not. I think that would be pretty rare. A re-examination of the smoke evacuation codes. Exit mask, right? I remember a time when you check into a hotel room and this wouldn't be on the door. Now every hotel that you check in has this. But most importantly, this led to the development of through penetration and joint fire stop, which now is second nature to every architect. So that was a big deal. Flame spread doesn't have to happen only on the inside, not flame spread, but fire and smoke doesn't have to happen on just the inside. The Grenfell Tower fire, which is recent 2017. Grenfell Tower was essentially public housing. You can see a picture in the upper right there of what it looked like when it was built in the 1960s. Kind of a plain, brutalist concrete building. And then down below that was how it was modified just a few years before the fire. This investigation is still ongoing, but I think it's pretty clear that the sponsoring area, the district that built this housing, the way it works in Britain is that every borough or every district is responsible for providing their own public housing. It was a lower middle income sort of area. They built this to all reports. It was a decent project. People enjoyed living there. I think what happened was that the neighborhood got gentrified. And they didn't like seeing this rather plain building in the middle of their town. So they paid to have MCM, metal composite material, put on the outside of the building. They also dressed up the inside of the units using plastic trim. They redid the windows. Grenfell Tower was a poured in place concrete box. So when you were in your unit, you had 6 concrete walls surrounding. Fire evacuation procedure was in the event of a fire, you stay in your unit, shelter in place, right? Because the guy next door could be, his place could be burning up, he leaves, he closes his door, the fire brigade comes in, puts it out, it doesn't spread. What the renovation did is it provided a path from the inside of the unit to this outside non-fire resistant metal composite panel. And the fire was started by a compressor of a refrigerator by the outside wall. Started to burn up. It went through the plastic trim. It went through non-fire stop gaps in the new window, caught the outside of the building on fire, and spread up. And of course, every apartment unit had the same condition. It went from the burning MCM on the outside of the building into the inside of the units. So you can see the damage here. 85 dead, quite a few, oh, wait a minute, I did the wrong sheet here. 146, no, 72 dead, 72 dead. The worst residential fire in the UK since World War II. Besides the recent renovation and the fact that stuff wasn't fire stopped, and the fact that the residents still were using the shelter in place plan in the event of a fire, it's looking like the cladding material did not comply with the regulations in place. Britain has a performance-based code, not a prescriptive code, right? Our code says everything over 60 feet needs to be fire retardant materials, right? Not clear exactly what went on here, but it is clear that every bit of the MCM on the outside of this building was polyurethane, it's not fire retardant. So the improvements, since we're still under review, it's hard to say, but NFPA 285, which is a multi-story burn test that we all have to do on buildings. It's unclear whether something like that is used in the UK. They're probably going to adopt that. Fire-resistant MCM is going to be required. Steve was telling me that the US manufacturers no longer make a non-fire rated material.
From what I understand, talking about product websites, most manufacturers have stopped making non-fire MCM.
So the building is still standing there. There's questions about what they're going to do with it. There are actually some people who want to restore it, move back in because they like living there. Restored obviously to a much safer condition. There's ideas of making a monument to people who died. One was using it as a planted garden. And current thinking, I think, among the council there actually owns the buildings that they're prepared for that. So if this building gets torn down, it's a catastrophic failure because the system reached the point where it was no longer usable. It would be a total loss of the building, right? Think back. The Iroquois Theater, not a catastrophic failure. After the fire, they restored the theater, they opened it up again, they had plays there for another 25 years, and then they tore down everything except the front and rebuilt the theater because it was a great spot and theater, design had gotten to the point where they wanted to make it a more modern theater. Triangle Shirtwaist was restored. Factories went in there. 2 years later, New York University purchased the building and currently exists as offices. Ever since the 1920s, New York University has used and occupied that building. And the MGM Grand, 2006, CSI convention in Las Vegas, Steve. Where did you and I stage?
That was about correct. Yeah, MGM.
At the MGM brand, and we thought nothing of it. I mean, I felt sick. Right? So those first three horrible losses of life really aren't classified as catastrophic failures. They're tragedies. They're terrible failures, but the building itself, survived. And that's an interesting distinction. I'm still trying to wrap my head around that sort of definition. Okay, while we're on the outside of the building, and we're going to do a bunch of it with no loss of life. So I think it's time that we did that. Failures of the building on the building. Fatalities 0. Injuries possibly 2. The John Hancock building, John Hancock Life is shown there in the middle. In its current glory, is a beloved building. Right downtown, it's by H.H. Richardson's Trinity Church. When it was built, and as it was being built, there was a storm with 75-mile-an-hour wind gusts. 65% of these, 65 panels in this building were sucked out, started flying through downtown Boston, right? And as construction went on, as there would be windstorms, more and more panels fell. And it got to the point that it was such a dangerous condition that they started, first of all, as you can see on the right here, infilling the panels with plywood panels. And ultimately, almost every window in that building was covered with plywood. Bostonians called it the plywood palace, right? This happened, I guess, right after I got out of school, and so it was a big deal. And I remember, as you know, many of us do, whenever there's a failure, we try to understand it and speculate about how it happened. The first speculation was the glass was being sucked out on the leeward side of the building, and that was disproved. Possibility of a nickel sulfide inclusion causing spontaneous breakage, that was disproved. And there was also foundation settlement when the building was built. So there's speculation that that settlement may have caused it. The actual cause of the failure was that the architect was using a rather innovative product for the time. It was one of the first large-scale uses of insulated mirrored glass. Now, you know, remember that 1960, less than 15 years before, was the first float glass as a product. We had polished plate before that. So float glass itself was relatively new. Insulated glass is also relatively new. And this mirrored surface was a brand new thing. 1970s, 1980s, it's really popular. What happened was there was a lead seal around the outside of the insulated glass, and the chromium coating was bonded to the lead seal. The lead seal was so stiff and strong that any sort of stress on glass caused micro cracking at that seal. And it weakened the glass, and when you got wind load on it, it would just explode and pull out and fly across the streets of Boston. All of the insulated glass ultimately was replaced with single pane tempered glass. They went back to a more tried and true technology. 10,344 windows, $7 million later. John Hancock is in all its glory, right? The improvements, incredible improvement in the technology of glazing, right? And I think our modern glazing systems really started with this building. The fact that we can tweak glass with heat transmission, light transmission, and all the stuff we can do with it. I think it started with understanding this. And then obviously the improved design of the spacers where they really work at. Chicago. This is another famous architect, no, not names here, so. This architect was a neoclassicist, so when this building was built in the 1960s, 1970s, that time was the tallest building in Chicago. His vision was to use Carrara marble. Now, Carrara marble is Michelangelo's Pietà, Michelangelo's David, the Pantheon, right? This is very, very white, very, very beautiful stuff. Has lasted for years in many important works of art and buildings. The image was that Standard Oil would present itself as this white, shining sort of neoclassic tower. At this time, new technologies in stonework allowed the panels, which were approximately 4 by 4 feet, allowed them to be sawn into 1 1/4 inch thick sheets, as opposed to typically you do maybe a 2 1/2 or 3 inch slab. So the building was built, everybody loved it, you know, the Standard Oil loved it, and the panel fell a few years afterwards. The problem was that Carrara marble is prone to thermal hysteresis. Thermal hysteresis is an expansion and contraction of the marble over time. It changes the cells of that marble to where it deforms. Well, you know, Rome, rather temperate climate. Chicago, not so much. Right? So 15, 20 years of freeze thaw deformed this marble. You can see a panel of marble being tested. It warped. And as it warped, architects would be familiar with the way we mount marble on a building like that. You cut a curve, which is basically a slot, the bottom and the top of the panel. And you have a folded plate, or you have an angle that goes up to that curve, and it holds it in place. Right? Well, now you've got a piece of marble that has maybe a 1/4 inch curve in it. That's only 1 1/4 thick. You've got a 1/2 inch on either side. That's difficult. That's probably workable. But then you get a panel that's deformed and it's starting to break off. The Standard Oil credit, I guess it was at Amoco at that point. To their credit, when it first started happening, they paid for an extensive investigation of the outside the building, and that gave them a baseline 5 years afterwards. And as these panels started to deform worse and worse, they would periodically come in and check the outside of the building and check it against panels that were staying in attic stock. And they finally decided that, you know, every panel in that building was in danger of possibly coming off. So they went back and they used stainless steel straps up and down to span the length of the panel, drilled into the anchoring system. And the building was covered with as many straps as there were panels. They painted it white, so it looked really, really ugly, but that was a temporary fix. That was to keep, you know, if you thought glass flying around Boston was bad, marble panels flying around Chicago would have been horrible. Ultimately, a decision was made. They took every piece of marble off the building, replaced it with granite. The thicker granite, it's a stronger stone. It's not prone to thermal hysteresis. And 88,000 panels were replaced, $80 million. Improvements, a better understanding of facade materials, a better understanding of stone out of this. But maybe most importantly, the lesson learned was when you start to have problems like this, and this was a long-term problem, this happened over 15 or 20 years. When you start to have problems like this, get them studied. Get someone that knows what they're looking about. This was Louis Jenny Elstrick, who did the work here. Look at a baseline study and then, compare. That's exactly what Standard Oil did. That resulted in 0 fatalities, 0 injuries. Staying on the exterior, that gray architecture. Not mentioning the names of the famous architects, and they are famous for architects who designed these buildings. The first one is the Disney Concert Hall in Los Angeles. I'll leave you to guess who the architect was. Essentially, the drawing there shows the concept of what's happening. When you have a curve like this, rays of the sun can hit it, focus, and that's what happened here. The concert hall was focusing at certain times of the day across the street and causing burns. People were actually getting burned by it. The other thing with this that you always see is local news goes and they fry an egg on the sidewalk, or they boil hot dogs. They did that with every one of these buildings. The Madera Hotel in Las Vegas is the next one. And this was focusing rays on the pool deck. Vegas is not a particularly wild climate anyway, but people were getting 30-degree burns. Well, the answer to solve that was to put more umbrellas on the pool deck, which is a great architectural solution, right? The answer in the Walt Disney building was they sandblasted the offending panels. And actually, it really didn't look bad. I was out there a couple of years. Really hard to tell the building in London, the third one, 20 Fenton Street, it's called the Walkie Talkie Building, was focusing rays and melting the plastic on Jaguar parked across the street. It pains me to think that Jaguar would have plastic trim, but apparently it does. The interesting thing is the star architect who did the Gara Hotel with the umbrellas is the same architect who did this building in London 5 years later. His comment when they asked him why he designed a building like this was, well, I've been to London many times. London is cloudy and rainy. Who knew the sun would come out like this? And went on with it, and that being for a while. And then he says, maybe it's global warming. Not to criticize star architects, but that building was corrected by putting a sunshade system on the first wall. And then we'll go on to another unnamed architect who designed a museum in New York City in the 1950s. Very notable piece of architecture. It was turning 50 years old, and the exterior is cracked. And they decided to completely renovate it and to get it back in shape that it was when it was built. This is a concrete, sprayed on concrete system, and it's painted on the outside. The first thing that had to be done was they had to remove 17 layers of paint to get down to the concrete. And then they did a laser survey of all the cracks. And this looks really bad. I mean, there's some micro cracks here, and there's some pretty bad cracks, but architects who are by age call, we learned the rule of thumb was expansion joints concrete every 30 feet, right? I mean, that was a rule of thumb that seemed to work. I actually showed this at Washington class yesterday, and talked to the professor about it. The thing that we both noted is look at where the big fat cracks are, right? I mean, that's God saying this is where you should have put your joints, Mr. Architect. And I'll get off of the slide basically by quoting it at Block, who was a big deal at the Masonry Institute. Ed used to teach a spec class and he'd say, to young architects, you don't need to put expansion joints in your building. You don't need to do it. But if you don't do it, your mother and father will take care of it. Mother Nature and Father Time. That's what's happening here. The fix on this was to put expansion joints in the building in the first place. I'm sorry, to make sure that you obviously know where your expansion joints go. But the fixes were carbon fiber strips, and you can see some going on the inside of the building here to help stabilize some of the movement in the concrete. Those strips were also put on the expansion joints that were added. There was an elastomeric coating that was put over it that had much more movement capability. And the Guggenheim is hoping that it's going to look just as beautiful for the next 50 years. Again, no deaths were caused. Okay. This notable building, which we all know and love, right, began to lean in the 12th century as it was being built, and the cause of the lean was soft ground. Construction was halted for 100 years as there were wars. Pisa was fighting other city-states. Nothing went on. And this probably saved the tower, because while nothing was being done, part of the tower that was already built settled and stabilized. And then they built the rest of the tower. By 1990, this tilt had reached 5.5 degrees, 5.5 degrees. And there was concern that it actually would fall. So you can see the fix. They piled lead weights on the backside of the tower. Was this in place when you were there? Yeah, this was probably before that. This was, I think, 1993. At any rate, that helped to stabilize it. I guess the question here is, who's to blame? Can we blame the designer, contractor, owner, developer? This happened a long time ago. And did they have the knowledge to understand what was going on? I'm saying that this was obviously a structural failure and a performance failure. Is it an aesthetic failure? Why would you go to Pisa if you were in Italy? Why would that be on your tour, right? It's art. It's art. Yes. Years ago, at the beginning of the internet, I used to do homework help for students who were interested in architecture and building stuff. One of the students in the chat room asked, what would happen if the Leaning Tower fell? And my response was they would build it back. There's a reason that I knew that. It's because my wife and I had been just back from Italy at that time. And we were in Venice. Our first morning at the B&B, we're having breakfast. And we're talking, and it was just a wonderful time. And I noticed that Maureen is looking like, not at me, but looking over my shoulder. And it gets this weird look on her face. And she said, is that the bell tower falling? Well, this photograph was on the wall behind us. And in fact, you did Venice, the bell tower that we're seeing is a reconstruction from the tower that fell in 1902. The tower itself, the one that fell, dates back to the 9th century. And it had been added on to over time. It was so important to Venice. It was actually the clock. The bells would ring at certain times to announce certain things that had to happen. There were lightning strikes, earthquakes, fires, all sorts of things. The top part of it, the roof part had burned down and been rebuilt. And by 1880, there were stalls, vendor stalls around the outside. They decided to get rid of them. They found that the base was in really bad shape. And rather than do an extensive repair, they sort of patched it up. Well, 1902, they were repairing a girder that supported the roof. They cut it out, and as they were pounding the new beam back in, the tower started to shake. And it shook and shook and shook over a period of a few days. July 14th, mortars started to fall. In the morning, 9:30, the square was completely evacuated, and 23 minutes later, the tower collapsed. Since they knew it was going to happen, there were a lot of photographs. And I am speculating that this may be the first building collapse actually captured on film. So talking about, what happens if the Leaning Tower fell. Money was allocated by the city of Venice the next day to rebuild it. And the province that Venice is in money with it. There was no question what would happen. So that raises the question of how do we decide to save a building? Right? The MGM grant, it's on the strip, a lot of money to do it. Right? The theater fire, the Sherman spectacular, they're all in economic plus places. Grenfell Tower, not so much. Grenfell Tower is probably not as damaged as the other buildings. If the Leaning Tower ever falls, or this tower falling, the economic loss will be considerable. Tourist trade, drives this. Okay, since we're talking about foundation failures, Millennium Tower, and again, this is still under study. A decision was made, an economic decision was made by the developers not to run the piles all the way down to bedrock. And as you've heard, no doubt we heard that tower 10 years after it was built, it sunk 18 inches and tilted 14 inches at the top. The fix, since this is in a very expensive area of San Francisco, the fix was to pour a beam under the foundation. You can see the detail there, and drive piles sort of just outside the building all the way to bedrock. That work started, I think, in the summer, and after a few months, they had to stop it because it was just making the tower sink more. So this is still being studied. This is an expensive neighborhood, an expensive building, in an expensive town. I guess our question is, with this failure, what's going to happen? Are they going to continue to try to save it? Michael Bird's going to be talking after I finally shut up here about a building that actually was faced with that question. This is something that probably no one in this room has heard about. The Algo Mall collapse in Hoyt Lake. This was a mining rich small town. And in 1980, they built a mall, hotel, government office, library, health center, underground parking, and rooftop parking all in one building. This was truly the community center. This wasn't just a place to go shop. This was truly the community center. Mining dried up in town. Malls themselves are less popular now, although even though the stores closed, they still have the library and stuff. But the building in 2012, a car drive driving on that ran over a joint, and a bay of the parking deck collapsed into the mall below, and 2 women were killed. A decision was made early in the construction to go with an innovative waterproof system that had just come out. And the theory of this system was that you wouldn't put a waterproofing membrane over the entire structural slab. You can see here, these are it's called core deck. Rather than waterproofing that, they would rely on the imperviousness of concrete and only seal and put membrane over the joints. A good decision, right? You can kind of see in this detail here all the different joints. And anyone who's ever had a roof leak knows that where the water comes in, it's probably not directly over where the water goes out. As the economics of the mall went down, you can see there was no maintenance. They were using buckets to catch water in the library, kept having to move books, and ultimately they had this tragedy. The mall had lost economic viability, so I think that economics probably enters into this as much as anything. Economics drove the lack of maintenance. Ultimately, this building was torn down. They're looking at what to do with the site now. But the good things that happened, the province started minimum maintenance standards for buildings with periodic inspections. Continuing education for engineers in Ontario was started. I can't believe that they didn't have it before this. Similar waterproofing systems, unsurprisingly, are not used anymore. We're away from that, I think. And advanced non-destructive techniques for measuring rebar corrosion are being developed. Derek Mashek was on our committee, thank you. Is in the process of putting together one of our panels that's going to discuss concrete restoration. And there's a group of his firm that they're going to be doing that. Talking a lot about some of the problems that happen here when there's a lack of maintenance. And this picture in the upper right-hand corner is vaguely familiar. It's from this project, but it could have been the one down in Florida. In the study of the condo collapse in Florida is not done. But, indications are that a dead level structural slab that wasn't properly waterproofed, causing corrosion and rebar, it's going to be the cause. And we'll end with this Longhouse Plaza in Bridgeport. Lift slab is something that's not much done anymore, but the concept is you pour your base slab, and then you pour 3 slabs on top of it, and then jack them up into place around the columns. And it was a very successful, very safe method of construction. It was used extensively in the 70s and 80s. There's a horrible failure here. And you can see in the drawing, they got up to the 6th level, and there was a collapse as the building was being worked on. "28 workers were killed in a horrible manner." You can see a composite of photographs taken the day after what mess this was. The important thing about this failure is the litigation that took place or didn't take place. This happened in 1987. Immediately, a federal 2-judge panel put together a settlement. There were 100 people, 100 parties involved. 40 of them were contractors, architects, and so forth. So they would have been the defendants and the rest of the plaintiffs. And what the judges did was they basically brought everyone in, everyone who was remotely connected. Had this conversation with Steve, and he was shocked, just like I was when I first heard this. The contractor was brought in, the concrete guy, that this and that, but they also brought in the drywall contractor, who had just signed his contract the day before and had no materials inside. They brought on the guy that drove the little silver truck that brought donuts, and they basically said, "You have a choice. You can either join our pool and make a contribution to a settlement, or you can be off on your own with danger of being sued." And there were 3 tiers. I mean, obviously the contractors were at the top tier. Their insurance company kicked in the most. The guy with the food truck probably didn't have to contribute an awful lot, but the ultimate decision raised $41 million. And that money was distributed to the victims within 8 months of the claims. So, the widows and the children and so forth, their lives, at least economically, nobody went out of business. If this settlement had been allowed to go to a lawsuit, and the people who we think of as the responsible parties, we all have an idea of who that might be, they would have been out of business. No question about it, because of the magnitude of the suit and the size of companies. It's hailed as an effective way to get relief to the victims, to keep the companies going so that they can employ people and so forth, and most importantly, to minimize the amount of legal time. Think of what would have happened with 100 parties, with all the different lawsuits. Think how long it would have taken. I mean, it would have been 7 years, 10 years, 15 years before all of this stuff had gotten settled. So I would ask you to think about this. Think about if it impacts your brain as being fair, not fair, a good way to do things, not a good way to do things. Our final panel will address this. We'll see what the lawyers and the insurance people think. I'm basically done. What time is the week?
Michael's got 10 minutes.
Seriously?
That's 20 after.
Oh my gosh. Okay, well, that's typical, isn't it? Michael's gonna talk about a project that failed and didn't kill anybody. And oh, okay.
I'm gonna try a different microphone real quick. Yeah. No, I think I'm good. Can you hear me better at all?
You can use this one if you want to.
I think this is okay. I think that will cover the audio.
All right, you lost everybody.
Okay. Well, I think George just invited Steve and I to participate here because you just needed 2 more to round it out and make it a magic 20 or something like that. So I've only got 1 building to talk about. And this one is like, when is a failure not? When is a catastrophe not a catastrophe, right? It is
this is an economic failure with a physical structural proportion to it. And as someone called it, it resulted in temporarily the most expensive billboard. The Harmon Hotel. So for those of you who are not familiar with Las Vegas, the city center project is a massive development. It is many millions of square feet on 76 acres, the largest privately funded development in U.S. history. It started off about $4 billion of budget to be a completely, self-contained lifestyle center. Everything, residences, retail, entertainment, of course. There was a grocery store, the first one on the strip that was planned, although it actually hasn't happened. There's even its own quote unquote sustainable power plant on the site. It's massive, and as if that weren't enough, it connects to other MGM properties. MGM owns something like 9 hotels and casinos in Vegas right now. And that's just the hotels and casinos. There are other entertainment venues that it owns. And then of course the worldwide portfolio at Balloon. It's built for 12,000 employees with 2,400 condos, twice as many hotel room keys. This was the concept, and it ballooned to $9 billion worth of construction. So this is like a drama, right? This is a very sad kind of drama in 3 acts, and this is our cast of characters. Now I've left out the many attorneys that are involved. We'll consider those extras, supporting players. But just so you know kind of the names of those who are involved, MGM Resorts and City Center for these purposes are the owner. MGM Resorts owns 50% with Dubai World owns City Center. And they are the owner, and they hired Adamson Associates Architects to be the executive architect for the entire City Center project, and Tudor Perini to essentially be the lead contractor for the project. Adamson hired the design team, which is Norman Foster and Partners, and Halco Gallus, which was at the time a Toronto-based, I guess still is a Toronto-based structural firm that is owned by a UK firm that got bought recently by CH2M Hill, that got bought by Jacobs. So consider it Jacobs. And Tudor Perini is a massive contractor who is still involved with massive projects, and most recently Hudson Yard. Tudor Perini hired Pacific Coast Steel, which is now part of something larger called Pacific Steel Group. And there's another player that comes up here, but I put them on a different group. These supporting players are the AHJ, which in this case is Clark County, Nevada. Clark County is big. It contains 74% of the population of the state of Nevada. And it's growing massively. And it is also in an active seismic area. So all of these complicating factors mean that Clark County has a lot of work to do. Clark County Development, the development entity, has a lot of work to do to oversee all this construction. They rely on ICC certified special inspectors, as do lots of municipalities. In this case, Converse Consultants out of California. And Converse works nationwide on lots of big projects as well. All these players are still around. And then of course the other players are the Clark County District Court, which gets involved, although nobody knew it at the time they started. And the state of Nevada that it represents. So Act 1 is the design starts, and everybody's moving on with this $9 billion project. In this initial model, it's called a lifestyle hotel. And originally the lifestyle hotel was actually about max tall, but program ballooned and the concept grew, and we ended up with a nearly 50-story hotel and condo concept, with condos basically stacked on top of hotel, and then some units that were would kind of be a little bit of both. The structural design, even it's an elliptical footprint. The structural design was challenging, but also somewhat traditional, and that relied on big 8-foot deep reinforced concrete cast in place link beams to transfer lateral loads across the structure. So I have never been personally involved with a big project like that, required structure like that, but link beams have an enormous amount of reinforcing, and the reinforcing is very precisely placed. The rebars are running very tightly together, 2-3 inches in between these bars. Of course, you're getting to the minimum amount of coverage because they need to be at the kind of extreme top and bottom of these link beams. So it was very tricky to install, and those link beams were designed to be cast in place with the floor slab, which made it even trickier. So Pacific Coast Steel had their work cut out for it. MGM figured that they had this sewn up, and they implemented what would be they kind of pioneered a scale of construction management, auditing, and project delivery that is heretofore kind of unheard of. So they had armies of auditors crawling all over the project and looking after many multiples of key performance indicators for the project. And it's become the model for which these other big projects have been delivered, like Hudson Yard, other projects international. You're talking about projects that are spending billions of dollars and are basically creating, small cities and have a huge impact on the local economy. And they factor in, some of those indicators factor in things like local government and what's happening, with legislation, and also corruption. Depending on where you are, that's a bigger or smaller concern, but it's definitely something that gets factored in. Incidentally, they claimed that this process saved them $100 million, which, as it turned out, was not that much. And I could not find any information on how much the process added to the project. Construction starts, and everything seems to be going swimmingly, as anybody can tell. And it goes up, the first few floors go on up, and nobody notices anything wrong. At 4 or 5, things start to get sketchy for Pacific Coast Steel. And in their later opinion, there were design problems, perhaps coordination issues between Foster and Halpro that made some of those rebar placements very, very difficult. This is where we start to talk about what is proximate cause and what is root cause, because things started to go badly with the contractors on site, and they started to make some decisions without any other approvals. So they started to figure, well, we can't really fit all this rebar in, so we're not really going to put it all in. And sometimes it was so tight that they could get it in, but they couldn't make it sort of small enough to fit into concrete. So to prevent it from sticking out, they would cut. So they cut many stirrups and rod caps and things like that. And all of this was getting covered with concrete as things proceed. Now you've got eyes on this project. So as all projects are, this is a team sport, and this is where you start to talk about what part of this failure is attributable to what thing. The bad workmanship certainly is proximate cause. I think you could also argue that the bad oversight was perhaps the proximate cause, because there's going to be problems. I mean, the system is designed to be tolerant of mistakes, right? And some shoddy workmanship, because we have oversight built into the system. The oversight is not a luxury. The oversight is a responsibility of multiple parties. Some of which are independent, so that they can speak on behalf of the owner without bias. However, both the structural engineer and the third-party special inspector, and to a degree Clark County, failed in that regard. So as things progressed, floors 5 through 20, these problems got overlooked. Literally buried in concrete in some cases, and in the case of Converse Consultants, seen but not noticed, or perhaps noticed but not noted. And the reports that Converse filed regularly with the county and the owner did not reflect the actual conditions. Halcro, the structural engineer, was of course on site, but didn't flag anything, perhaps because a lot of it was concealed. But eventually they did notice something. And in July of 2008, Halcro engineer is the one who brings everything to light. And structural engineer reports that there's a problem on the 26th floor. And then on subsequent floors, once they start looking, that this rebar has been placed incorrectly. The county issues a notice of violation, and the closer they look, the more they find, and they know inconsistencies in placement, floor to floor, which means they made mistakes on one floor and they made a different mistake on the next floor. And there was no real explanation found for why the incorrect approach wasn't even consistent. It just seemed to be sloppy in these link beams going all the way up. And all that leads to some interesting consequences, because as we've said, this one did not result in any deaths. The building was not occupied for its intended purpose. They stopped at that 20, depending on how you count, 27th floor, and didn't proceed with their construction. It was determined that the building had structural deficiencies that would imperil it in a seismic event, but it was not going to fall just on its own in normal circumstances. So nobody died. Were laws broken? It was a little complicated. Certainly policies were broken. And Clark County Development took some of these folks to task, as did the Nevada State Contractors Board. And they imposed their own judgments and fines, which, given the kind of nature of things, may seem a little light, but of course, the real justice comes a little bit later. Pacific Coast Steel paid a small fine, and the firm did not have to admit fault to the state board. Converse Consultants was basically suspended from working in part of the state of Nevada for 6 months. And the inspectors that falsified the reports lost their credentials. I think there were 2 inspectors in question. The owner, now seeing a lot of things that have happened since the project was envisioned, is thinking now that they're gonna abandon finishing the project given the circumstances. And why shouldn't they? Because when the project was conceived, Las Vegas was booming and there was no end in sight. When construction started, the Great Recession happened. And all of a sudden it seemed like Las Vegas did have a maximum. And it didn't need another 4,000 hotel rooms, in addition to the other 4,000 room hotels that have been constructed in the last previous years. So the MGM Resorts decided to limit the project at first, which of course would save them a lot of money right up front. And then of course they had to go about figuring out what they could do with the property as it was. They decided to cap it and leave it as hotel without the upper floor commons. But that didn't last. Because now everybody's in court. And the longer it goes, the worse the economic output of the project gets. And MGM decides that it is actually in their best interest to simply demolish the project. They don't need the additional 2,000 hotel rooms that are on those lower floors. They've already built other hotels by other prime architects in City Center alone. So they are now making the argument that the building shouldn't be allowed to stand. It is dangerous. They marshal experts on their end to do reports that attest to the building's structural insufficiency. Meanwhile, Perini, of course, is arguing the opposite, because they have hundreds of millions of dollars on the line that they have not been paid for in building that, the first stories that they built. And so they are arguing strenuously that the building actually can be salvaged and repaired, and they get their own engineering done that says that for $20 million, they can occupy those floors safely. It goes to the state, and the state at first says, yes, you can demolish it, and Green argues against it, and gets some court somewhere to rule that there's a problem with some of the testing that suggests that the building has an overarching problem, not just some localized problems. That determination goes to the state Supreme Court. The state Supreme Court agrees with the initial ruling that the building can be determined to be fundamentally unsound. So demolition can proceed whether Korea wants it to or not. And so that's what they move forward with. The demolition cost is $11.5 million. And Clark County requires the entire city center project to retest everything Conference Consulting is involved with, and asserts that they have kind of final say on the results of those retests. And so the building is demolished. It used to be right here in this corner of the project. It is no more. There was $500 million on the line. Everybody settled for undisclosed amounts. County and the courts find fault with both PCS and Conference Consulting. And MGM has a study done themselves that points some fingers at Halcro for some of those design problems. Some of those problems may be related to things that were not related to link beams, but those deficiencies surely were used to bludgeon in the settlement negotiations. So between 2014 and 2015, the whole structure is removed a piece at a time, and City Center operates very fine without it. And the entire thing, of course, isn't known as City Center anymore. It's the ARIA. And so this sad play comes to an end, and everybody now has kind of looked back and made some determinations as to what could be changed, why, and who really deserves to pay and why. Clark County, of course, has to rely on those third-party inspectors. Their process of employing monitors to spot check the work of those inspectors continues. But of course, everybody takes it a little bit more seriously right now, but they have not made changes to their funding process. They did note in their analysis that their monitors did tend to examine rebar on the foundations more strenuously, rely more on those inspectors for the upper floors, which is a procedure that they are reviewing or have reviewed and made changes to. I'm not sure if those changes fit in reality. The lawsuit between MGM and their contractor led to a couple of things that I thought were interesting. PCS, the Pacific Coast Steel, got sued, of course, by Kareem. And this is one of those situations where it matters, because we're not talking about criminal things, we're talking about contractual things. It matters who works for who. And it's difficult to make third-party claims given the nature of these agreements. So it becomes, the big numbers come down to MGM and Tutor Kareem, PCS. And then secondarily between MGM and the structural engineer through the executive architect who gets sued by them as well. PCS, because they got sued by Tutor Perini, turns around and files a complaint against the structural engineer. PCS does not work with the structural engineer, of course. So they are filing, they're trying to assert professional negligence. However, that's a difficult standard to meet. And they instead tried asserting negligence, that they negligently misrepresented the circumstances, because it was about the professional negligence came down to, does the fact that Halcro didn't do their inspections in a timely fashion suggest that they didn't do their design work in a professional manner? Were they in fact professionally negligent? That turned out to be very difficult to show. So the allegation of negligent misrepresentation was tried, but ultimately it didn't work out for PCS. I don't think they got much of anything. So, any questions? For right now, any questions?
While you're setting up, if I could ask, the concept of special inspections is fundamental to practice and construction these days. Does all of this bring that into question, or is it still?
No, I've read nothing that suggests that anybody is questioning the process. And maybe that's because no lives were lost. And because even though it is a monumental, economic failure, in the grand scheme of things, even in the scale of city center, it was surrounding here.
But there was a question related to the testing quality by PCS, or I'm not sure.
Converse Consultants was the third party. And they completely failed, of course, and they misrepresented 62 different reports.
Yeah, but there's no questioning the relationship between the owner hiring the special inspectors who are essentially acting on behalf of public agency. That's
Not that I have read. I've read nothing that suggests that any of those parties are reconsidering that relationship. Maybe because nobody has a better arrangement.
So while I'm getting set up, just got one question for Drew and Hank. While you're paying attention to George's presentation, I just got 2 words for you guys. Structural paint. Structural paint solves all the problems, right? So I couldn't help it. I ran across this quote from Larry the Cable Guy. We're going to talk about a very serious subject here, but to lighten things up a little bit, so we're talking about death and destruction, and we're going to talk even more about death and destruction. Let's go to a real quote though. Technology is there today to give early and normally ample warning when a tornado is a possibility. Okay. So what I'm here to talk to you about is Joplin, Missouri, 2011. Joplin is the 4th largest city in the state of Missouri. Normal population is 49,024 people, but the daytime population brings it up to 270,000 from people coming from surrounding areas of the surrounding minor cities like St. Louis. The area population is around 400,000 people. If you're not familiar with where Joplin is, if you take 44 south and right before you hit the Kansas border, turn north, you're in Joplin. And it's located right in the area that's currently known as Tornado Alley. Meteorologically, that's a tough word to say sometimes. It's ideally situated for supercell thunderstorms, meaning the strongest of the strong thunderstorms roll through here frequently. And they produce tornadoes rated EF2 or higher. Is everyone familiar with the enhanced Fujita scale? That's the EF rating for tornadoes. It goes from 0 to 5, 5 being the highest. So some facts for you about what happened in Joplin. On Sunday, May 22nd, around 1:40 p.m., the National Weather Service issued a tornado watch. Tornado watch, if you're not aware, is the conditions are highly favorable for a super strong thunderstorm, possible tornado. The conditions are very favorable. Well, a tornado warning was issued at 5:17. A sheriff's deputy saw a funnel cloud, so he reported it, and they in turn sounded the sirens at 5:17 and at 5:31. At 5:41, there was a tornado. The tornado touched down in Joplin. Doing the math a little bit, that's 24 minutes of prep time between the warning and when it got to the city of Joplin. So you had 24 minutes to seek shelter. Okay. For this tornado, it was an EF4-5. That was at its peak. And you're gonna find an EF5, they stopped measuring winds at over 200 miles an hour. Okay. just to give you the idea of how strong this storm was, and it wasn't just one vortex. You know, you think of a vortex as one, it was a double vortex, the 4 or 5 tornado. It was 3/4 of a mile wide in the city, but it got up to a mile wide when it got outside the city. The total path, it traveled for 22.1 miles from the city out to the east. The Joplin damage path was 3/4 of a mile wide, it was 6 miles long. It damaged over 30% of Joplin, and they calculate over 3 million cubic yards of debris were hauled out of that area at the end of that. The wind speed in excess of 200 miles an hour. That's what they could calculate based on the damage that they saw. Unfortunately, 161 people died. And that's the deadliest tornado event in the United States since 1947. There were over 1,300 people injured in that tornado. So this kind of takes you through the development of the tornado. You can see, starting here is where the little letter I is where the touchdown was. See, it rapidly turned into a 2. You have 2, 4, and 5, 5, 5, right over the heart of the city. And I went to 5, 4, 3, 2, 1, and it tapered out and it went away. 22.1 miles long. This is the damage path through the city of Joplin. The red is the most severe area. And I'll tell you, the reason I'm so interested in this tornado, I don't know how many of you are aware of the Missouri Safe Coalition. Has anyone ever heard of that? Some. Okay. The State Emergency Management Agency of Missouri had a law passed several years ago where they train architects and engineers on a volunteer basis to do structural assessment, visual evaluation. That's what SAFE stands for. When you do this on the behalf of the State Emergency Management Agency, you are held harmless from anything you do during that deployment under their guidelines. So as an architect, as a licensed architect, I cannot be sued if I were to do something in good faith representing the state of Missouri. So I was down there for this, doing some building inspections. And the red is virtual devastation. There's almost nothing. You'll see some photos. Give you an idea of what Joplin was like before and after. There's a corner before, approximate location at corner afterwards. Nothing left. No limbs on trees. Trees were just, if there was a tree still standing, it was just the trunk and some major branches. This is a satellite photo before on the right-hand side. And what I found interesting was this nice brown swath here, which is total devastation. And what you can't tell from these photographs, and what I noticed when I got off of it, who's been up in their attic anytime recently notices that smell. It's sort of a musty insulation type smell. That's what the city smelled like. A giant attic. Didn't help that it was 80 degrees and highly humid, but you know, that was it as well. So the damages, thousands of structures were damaged or destroyed. Single family housing alone, 4,380 were destroyed, 3,884 were damaged. Multifamily housing, there were a lot of apartment complexes there that got damaged. Large retail got damaged and public buildings got damaged. The most notable damage you may have heard, you probably heard on the news, St. John's Regional Medical Center. Home Depot was destroyed. There was one wall standing on the Home Depot. Walmart was destroyed. Cell phone towers, there were 50 damaged that were not functioning, and 10 of them were totally destroyed. This like kind of shows you what happens. Here's a tower laying down right here on its side. Fell across an apartment building. Standing next to this one, you can tell the displacement, the telephone tower, or the electrical pole just got bent. St. John's Medical Center is totally unsafe. They moved 183 patients out within 90 minutes of the tornado touchdown. They had nowhere to go with them. They found shelter for them. 5 patients died, mainly in the ICU. The electrical failure of the building. That is the main hospital in Joplin. and one visitor died from damaged debris in the hallways. Working with SSE engineers who was down there at the time, at the time I worked across the street from them, in Kirkwood, and SSE was down there evaluating the hospital. They said that the hospital itself was displaced off the foundation by a few inches. That building was moved a few inches off the foundation. I don't know what that was built. So this is the basically the head inspector, Steve Coe. There was a few thousand people volunteered to go down and help evaluate these buildings, and from Sunday to that Saturday, we were able to knock out all the buildings, a little over 6,000 buildings, evaluating, putting tags on buildings, those red, green, or yellow. Red being unsafe, yellow being safe to occupy part of, green being it's all fine. I just said that. Of the buildings, though, 38% were deemed totally unsafe. Of that 38%, I'd have to say 25% there was no building. It was just a foundation. 6% were accessible with restrictions, and 56% were green. That's how drastic it was from red to green. There was almost no in between. You can see this on this map here. There's almost no yellow on this one. It's either a good building or a destroyed building. We didn't qualify. We just evaluated them by address and the city and what was at that address. So they just knew that it was a business or a residence, that business. This was an interesting one. You think this is bad? This isn't bad at all. But this house was picked up and moved off of its foundation. And the reason you can tell is if you look here, it's the front porch. The front door is over here. So the whole building was just moved off of its foundation. And you're talking about proximate and root causes. Well, we know the proximate cause, right? Tornado. What's the root cause? Well, it looks pretty good. We got a sill plate. We got anchor bolts. Well, let's look a little closer. Oh, wait. Oh, where'd that course go? The entire course of masonry was just lifted up off of the adjoining course below. There was no reinforcing steel in there, nothing. The cells were not grouted solid. There's no basement in this house. It's a crawl space. But you can see where it was just picked up and moved. And, upon further review, you can see where the floor joists were. Right here. They were probably just end nailed to the band board, and it was just set on the foundation. They weren't tied to the sill plate. So God just decided to move that house a few hundred feet, moved it over. This one was weird, okay? So this house and the one next to it, the white one you see in the background, we come upon this, remember that picture I showed you, that corner that had nothing in that foreground? Imagine that neighborhood, this house sitting right in the middle of all that. We're looking at that corner. Why is that house still there with, the garage doors were damaged, looks like some shingles were ripped off, but why is that house still there? So the two older gentlemen were on the front porch, and we walked up to them and just said, we're with the state of Missouri. We'd like to look a little closer at your house and see why it's still here. I mean, thank God you're here because they were older, they couldn't take care of themselves anyway, but they were giving water to everyone else around them. And they said, sure, no problem. Well, we walked around the building and we discovered this. This is the back porch. See this metal strap right here? We asked them when they put those metal straps in. That metal strap goes from the wall past the band board to the foundation and connects it. So they've tied everything together. Their whole house was tied to the foundation, so it couldn't move. That's why that house was still there. So as a little teaser for you guys, in February, I'm going to talk more about how this proximate and root causes, because there's no one to blame here. I jotted down some notes when we were just talking. I just grab them here real quick. There's no one to blame. But what came out of this was a realization that we need to do things better, and a realization that we can protect ourselves because we do have the time to get into a safe location. It's not like a hurricane. Hurricane sustained winds up to 150 miles an hour, maybe a little greater, maybe less. You've just got to sustain that for a few days. A tornado is instantaneous. It's on you and it's over. It could happen multiple times in the same day. Think of that. That same year, there was multiple tornadoes in Edmond, Oklahoma, and a few other locations. And I'll show you some slides from Edmond, Oklahoma too, where the failure, these are from February, I'll come back. The copings failed. They were ES1 certified copings. They were designed to withstand tornadoes. They did. They just happened to be a couple blocks away, attached to the board, which was supposed to be holding them in place. So it's all about construction and making sure that we design and build these things in the right way so that people can survive these events. One thing that the hospital did, I was fortunate enough to be working with a company at the time that was asked to redesign the Joplin Hospital. And they said, can we make this building tornado proof? Well, we can't make anything proof. We can make it as tornado resistant as money will allow. How much do you have? At the time, no one had designed, here's an idea for you and Steve. No one had designed, and to my knowledge, no one still has, other than one person, a tornado resistant window. Because it has to be tested to such a high degree of impact.
Well, we're doing a ton of work with Miami-Dade with hurricane.
Exactly, there's a lot of hurricane rated windows. But hurricane is a sustained wind, not in excess of 200 miles an hour. You know, you got to fire that 2x4 at 200 miles an hour at 5 locations on window. It's not going to survive. So what I want to talk about in February is I want to talk about with the panel FEMA 361, 320, and ICC 500. What happened in Joplin is when these buildings got rebuilt, the high school was demolished. In that high school now, they have 3 locations that are storm shelters. And the federal government paid for them. Basically, they have no windows. They're concrete construction, floor, walls and ceilings. They've got tornado resistant doors, which are very heavy, very expensive doors. And they can be closed off in an emergency and they will hold in place. Their gymnasium, their library, or cafeteria in the high school. I'm not sure what St. John's did down there, but we were in discussions about hardening the ICU and the cafeteria. Those are the only real places that they could do it. This is not an option. Clever idea, but it is not an option. And finally, some tips: construct an appropriate storm shelter. Or this was left over. There used to be a bank in that parking lot. The vault's still there, but the bank's gone. Or this is the best advice I'll give you tonight. On your way out of your house into your basement, okay? This is the second best option. Place some hot dogs and cheese slices in your pocket so the search dogs find them first. Yeah. That's it for me for now. Make sure you sign the sign-up sheet. I got it up here. If you haven't done it, you need credits. Want to thank Hank for live streaming the program and Ella for sponsoring our food tonight. Thank you all. Actually, are there any questions for
Yeah, I mean,
George, Michael, or myself?
we're at 8 o'clock. We said we'd be done by then. If you need to leave, that's fine. If you want to stay, I know Steve and I will stay, and we'll make Michael stay too. So
Yeah, we'll stay as long as there's beer in that cooler.
Anybody have any questions for any of the 3 of us?
I'm surprised the hospital took that much. Because aren't they built to like a really high standard?
That was- No, go ahead, Joel.
Oh, no, I just said it's kind of relative. They are built to a higher standard, but when you start talking about the pressures and winds and the hurricane, that's even higher.
Yeah, you're talking such extreme wind speeds. It's really hard to, it's hard to design for.
But I mean, if these things are
But they were, I want to say that building was built in the late sixties or seventies. I'm not 100% sure, but that would be my guess based upon what it looked like. They didn't give it much thought back then.
I would just have an observation. To me, it seems like a lot of what we design and build today is designed with an economic life in mind. 30-year roof, 50-year shingles. You could do any building product like that, and it's code related, but it's also kind of expectations in society for how long something will last. And I think there's a lot of emphasis today also on the effects of what the financial and insurance market says is acceptable. There's building code requirements would set a minimal standard. Unfortunately, oftentimes that's also the maximum level of quality that wants to get built. And I think the examples you cited here resulted in some changes. And it could have been that there were architects and builders at the time that said, you know, I've got a better idea about how the doors on this could swing. And somebody said, well, is it building code required? And the answer was no. Answer given, and you move on. But I mean, when we talk about economic life, some of the things that we might think of as failures, not failures at all, they're just products and systems reaching the economic life. The other aspect we have today, I think, is in the category of the biological and health risks. You know, we have, I mean, years ago, there were the problems that came with Legionnaire's disease, you know, which had, they found their origin over time in the water treatment of cooling towers, right? But it took a long time for people to figure out what was causing this illness. And it happened a lot of different places. And now we're in the days of COVID and God knows what else is out there. So I think some of these definitions of failure, I don't know if it's failure as much as it is products and systems ending their economic life, and then the whole idea of that biology and healthiness of the environments.
Well, and like Joplin, for me, indicates we're continually learning from these disasters, these failures. You know, we learn from our mistakes, hopefully.
Did they rebuild that hospital?
Yeah, the hospital has been rebuilt. I'm not sure who did it. I know it was a McCarthy thing. McCarthy was the design builder, but it's been completed for a few years. And I know they did take into account radios and a higher level of construction. I think instead of just structural steel studs, no offense, they used CMU on the exterior scan, some other things like that. Your stuff's so good.
I mean, the importance factor for that.
It's the importance factor on the hospital is still 1.5.
Should be something.
No, it's still 1.5.
Let's say, but actually, just coincidentally, and according at the time, but since then, you do have new FEMA rules, you have new shelter rules
Yes.
that have come on since then. I don't know if some of them are in development, but I think those just push that development, and that's the way the building codes have always kind of gone, you know. The Sherwood factory fire, the Copa Cabana fire, these different events always push change to the code and cause things to be adjusted and refined, updated.
Well, yeah, so I thought originally of that Chicago theater, that was so just look at the codes that came from Chicago. That's what the 1800s. And it was still. It was 1850, wasn't it?
I think it was right. Well, and you look at the advertisement you showed, George, where it said fire, the building's fireproof. I wonder if they did that because of the Great Chicago Fire. You know, the other thing too is, some of the, Joel usually pointed out, some of the storm shelter requirements became code mandatory in 2018. Or we'll point that out in February. But the FEMA 320 and 361, if I remember correctly, those have been around for years. They just haven't been enforced.
What are those for? What's that?
FEMA has guidelines. If you get FEMA money to build storm shelters, you have to build it according to their guidelines. And their guidelines are, you know, if you're doing it for the public, it's got to have restroom facilities. If you're building it for yourself in your basement, it just has to have a certain number of square feet per person for 15 minutes, 20 minutes.
And then if you see this NFPA 280,
I'll have to look into that. I'm not aware of that.
George, you mentioned the, the fire changing code. Big urban city fires change zoning codes too. You look at ancient Rome, you look at Chicago, you look at the fire we had here in 1843. Every one of those massive urban fires changed zoning codes, right? We had to have wider streets. We could only build to a certain height. And that's something that's also fundamental.
You know, I studied in Switzerland at the time. When you build a school, every school community would get a funding allocation from the federal government for a field hospital and a certain amount of water storage, emergency generators, and other things. It was considered critical. They did it in every school building that was built.
And one other thing, look at the World Trade Center. What's come about of that? Fire resistant, or fireproofing has to be a certain construct now. And you have to have photoluminescence egress stairs over a certain height now.
Well, that came about when there was a fire in the World Trade Center
That's right.
earlier. That came about with the, getting luminescent stairs. So that was all right.
And there's some chat questions. I don't know if, can we get to one here, Michael, or? There's some chat questions. Do we need to try and get those?
All right.
Oh, okay. Hank left. What about the chat questions?
What about what?
There's 7 chat questions. Do we need to?
Oh, hang on. Some of them are just asking for certificate.
Okay.
I'll take a picture of those. So yeah, what I'll do is I'll download the chat. Yeah, people are looking for.
Hank, it's easy like on the chat.
Right.
Listen for a certificate. Were there any questions from the chat?
No, not that I'm seeing right now. Yeah, Teresa Warren here.
Okay. Thanks everyone online.
Yeah, thank you for joining us. Thank you for joining us here, and we'll see you at the December holiday gala.
Yes.
And we'll see you back for the next program in January.
Thanks all.
Great, thank you.